Hello. Yeah, can you hear me? Yeah, okay. So we'll do some examples on this VSE PR theory. Find out the structure of these molecules or ions. So the first one is IO3 F2 minus, IO2 F2 minus, XeO2 XeF4 XeF2 XeF2 ICl3 NO3 minus NO2 minus. Done, finished. If you know the bond pair and lone pair, you can find out the shape, no? Yes. So you see this. First of all, we'll find out the valence electron. So valence electron for this one is 7 for iodine, 7 for fluorine. So 7 into 3 plus 6 into 3 plus 1 because one negative charge is there. 21 plus 1, 22 plus 18, that is 40 electrons we have. So we can say 5 bond pair and 0 lone pair here. So 5 bond pair and 0 lone pair, the structure is TBP, tetrahedral, sorry, geometry and shape is trigonal bipyramidal. Okay, here if you see the valence electron, 7 plus 21 plus 1, 22, 22 plus 12, that is 34. Is it 34? 34, right? So 34 divided by 8, so we have 4 bond pair and 1 lone pair. Geometry, if you see, geometry is TBP, trigonal bipyramidal, right? Shape is what? Shape is here seesaw. Seesaw, the shape is. If you look at the geometry here, so what we do, we draw a triangle just to understand the shape. We draw a triangle. It's not like the bonding is there, just to understand it, right? And we have, suppose, one atom present over here, that is I, okay? One lone pair will be at this position, any one of these three. So I'll place it here. And then 2 fluorine and 2 oxygen. If you look at this, this looks like a seesaw geometry, okay? One more thing is important here, I'll just explain it here only. In trigonal bipyramidal geometry, there are 2 types of bond length in trigonal bipyramid, okay? This bond is the axial bond. Right down here. This 2 bond, IF2 bond we have, this is axial bond. And this 3 bond, 1, 2, and 3, these are equatorial bond. We have 2 different bond lengths also. Suppose the axial bond has bond length L1, equatorial has L2. So the bond length of axial bond L1 is greater than L2. Okay, this you must take care of. The bond angle here you see between this bond and the plane of the triangle, this bond angle is 90 degree. This bond angle is 120. This is 120 in the plane of the triangle. And this bond angle between this bond and this plane here, plane of the triangle, it is 90 degree. 2 different bond angle we also have here. So if you have 1 lone pair, yes, Hariharan. If you have 1 lone pair, it will place over here. If you have 2 lone pair, another corner of the triangle. 3 lone pair, another corner of the triangle, right? So this position will place the electron because the bond angle is 120 and here we have lesser repulsion, okay? This you must take care of for TBP, trigonal bipyramidal. You can't say it is a seesaw. See, suppose we have a line, this line is coming towards me, this part is coming towards me, and this part is going towards you, into the plane of the screen, right? So this is the, you can say here, this particular thing is placed. So this looks like a seesaw. This part is nothing but this bond, and we have this line. Okay. The bond angle you are talking about. No, here, see, ideally, this is the ideal thing I'm talking about. Okay. This 120 is for ideal when there is no lone pair. I should not place a lone pair over here. This is for the ideal thing I'm talking about. when there is no lone pair. Yeah, this angle is lesser than 120. If there is lone pair present, then this angle is lesser than 120. Okay, XeO2, the number of valence electron you see for XeO2, 8 plus 2 into 6, that is 20. Right, so we have 2 bond pair and 2 lone pair. Right, so it is, geometry is tetrahedral. Shape is what? Is V shape. We also call it as bent shape, or we also call it as angular. All three are same thing. XeF4, valence electron, 8 plus 7 into 4. That is 36. So 4 bond pair and 2 lone pair. Geometry is what? Octahedral, square bipyramidal. Shape is square planar. Clear? No doubt? Okay, next one. XeF2, valence electron is 8 plus 14, 22. So we have a 2 bond pair and 3 lone pair. See, the bond pair is always equals to the number of outer atom. 2 fluorine atoms, 2 bond pair we must have. More than 2, it's not possible. Okay, 3 chlorine atoms, you'll see here 3 bond pair must be there. Right, so it is, geometry is what? Geometry is TBP, trigonal bipyramidal. What is the shape? Shape is linear. All 3 lone pair present in the corner of the triangle. Okay. ICl3, valence electron, 7 into 4, 28. So we have 3 bond pair. See, 3 outer atom, 3 bond pair, and 2 lone pair. So it is T shape. Geometry is again TBP, and it is T shape. NO2, nitrogen is 5.
Sir, the bond pair can never be more than the more than
Outer
the outer.
atom.
Yeah.
Yeah, it's not possible.
Okay.
Valence electron, NO3. So we have 5 for this, 6 for this. So 6 into 3, 18, 18 plus 1, 19 plus 5, 24. So we have 3 bond pair here and 0 lone pair, right? So it is trigonal planar. Geometry and shape. NO2 minus. It has valence electron is 18. So it has 2 bond pair and 1 lone pair. So it is also, what is the geometry? Geometry is trigonal planar. Shape is V shape. Two and one you see bent or V shape. Understood? Few more examples will do. Find out for CH4, NH3, H2O. Done. What is the number of valence electron you are getting here? Yes, here the trick does not apply. Since hydrogen form duplet, it does not form octet. Okay. So what you need to do, whenever write down one note here, if hydrogen is the outer atom, if hydrogen is the outer atom, then we divide it by 2. Then we divide it by 2. Okay. So all the molecules you see, the valence electron is 8, 8. So we divide it by 2. So number of, you see this 8 divided by 2, we are getting 4 here and no remainder. So in this we have 4 outer atoms. So number of bond pair 4, lone pair 0. Here we have only 3 outer atoms. Out of 4, the number of bond pair is 3 and lone pair is 1. 3 plus 1, 4. Here outer atom is only 2. So number of bond pair is 2 and lone pair is 2. So all these are tetrahedral geometry. This one is pyramidal shape. Pyramidal. And here the shape is V shape, V bent angle. Done. Tell me, no doubt understood all of you? To find out the geometry and shape. Right. Okay. Write down next factors affecting bond angle. The last thing for today. Factors affecting bond angle. The first one you write down. Effect of lone pair on central atom. In that case, we have to draw the structure, Madhav. If you have different kinds of atom, then we have to draw the structure in that case. Okay, we cannot do it by this method. Okay, actual thing is that Lewis dot structure that you need to draw. Okay, these are the trick. So it won't apply for all the molecules, but with this particular thing, you can do most of the question. 99% of the question you can solve. If there are different kinds of atoms, hydrogen plus any other atoms present, then actual thing is that only you find out the valence electron, draw Lewis dot structure, and then you find out the number of bond pairs. You can find out from that. Okay, write down as the number of electrons on lone pair on central atom increases, bond angle decreases. number of electrons on central atom increases, best example we have theta 1, theta 2, and oxygen theta 3. So theta 1 is maximum, then theta 2, and then theta 3. As the number of lone pairs on central atom increases, bond angle decreases. Second one, effect of multiple bond. Effect of multiple bond. Right on, the multiple bond contains more charge and hence causes more repulsion. More repulsion, which increases the bond angle. Which increases the bond angle. So if this is theta 1, this would be also theta 1, this would be theta 2. So here, because of the double bond, theta 1 is greater than theta 2. Multiple bond causes more repulsion. Multiple bond contains more charge, causes more repulsion, bond angle increases. Third point, effect of electronegativity of central atom. Effect of electronegativity of central atom. Write down, as the electronegativity of central atom increases, bond angle increases. As the electronegativity of central atom increases, bond angle increases. NH3 and PH3. You see what happens here, obviously, theta 1 is the bond angle here, theta 2 is the bond angle here, then the theta 1, the bond angle is greater than theta 2. Why it happens, you see, since nitrogen is more electronegative, it drags the bond pair of electron towards its side. So here the bond pair electrons are towards the nitrogen atom. Hence they are coming closer. And this tendency is more because of the more electronegativity of nitrogen. They are coming closer, hence produces more repulsion, and the bond angle expands here. Theta 1 is more than theta 2. Done? Okay. Fourth one, effect of electronegativity. You want me to go back, Pranav? Okay, just a second. Of outer atom. I'll share the notes anyways. Not a problem. Okay. Of electronegativity of outer down, as the electronegativity of outer atom increases, bond angle decreases. Electronegativity of outer atom increases, bond angle decreases. Just reverse of the previous one. But in this we have some exception that you must remember. In case of H2O, the bond angle is θ1. In case of F2O, the bond angle is θ2. In case of Cl2O, the bond angle is θ3. Right? This is an exception here. Here the order is θ3 is maximum, then θ2, and then θ1. Right? This is an exception you must remember. Okay. One more exception we have here in case of PF3 and PH3. The bond angle of PF3 is more than to that of PH3, and this is also an exception we have. Understood? Yes, ideally it should be fluorine should be least, then chlorine, and then H. But it is other way actually. Double bond will have the mole preference. When you have a double bond present, so we just simply consider the bond pair repulsion. Okay, Aditya? Fine, guys. So we are done for the session today. Okay. Next class, you remind me, we'll start the new theory here, theory of bonding, that is valence bond theory. Okay. So all of you write down the heading, valence bond theory. We'll start this the next class. It's the Lewis structure. I'm sorry. Just a second. See, the valence electron you are getting is 32. So sulfur, oxygen, 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 and oxygen. 1, 2, 3, 4, 5, 6, 7, 8. And each of these oxygen atom has 6 lone pairs, or 3 lone pairs electron. And there's no lone pair on the sulfur atom. Now, in this, the negative charge, the formal charge is negative, 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 and +2 on the sulfur atom. According to the rule, when you have a hypervalent atom, the charge on the central atom should be either the charge on the ion, which is -2, or 0. Right? So in order to make it 0, we'll shift one pair of electron from oxygen to make a double bond over here. So one pair will shift here, another pair will shift here. The advantage of this is what? Both oxygen atom will have 0 formal charge, sulfur will also have 0, and oxygen has 2 negative charge here. So this is the Lewis structure of SO4 2- according to the rules that we have. Now, why can't we make any double bond here and make it to -2? Because if you do this, then sulfur will have 2 negative charge, oxygen will have 0 charge here. If any negative charge you have to place, then we'll try to place the negative charge on more electronegative atom, which is oxygen here, not sulfur. That's why this structure is more stable than the other one. Hence the structure is this. Clear? Fine. So heading all of you write down valence bond theory. Will start in the next class. Let me know this. Valence bond theory we have to start with. In this only we'll see the bonding, the hybridization theory we'll discuss here only. Okay? Solve the modules questions related to VSEPR. I'll share one PDF also with you on this VSEPR. Thank you guys. Take care. Bye-bye.